Hi students, today we are going to prepare aldehydes. So this video is for preparation of aldehydes, how we can cook them, how we can prepare them. So think about a scenario. If your mother tells you now, just go in a kitchen and prepare something, right? Aldehydes say. So what are the ingredients? What is the recipe? What are the different steps? When to mix what? So these things will come into picture. And in chemical reaction, we can say what is the main thing which we are going to have. Okay, what is the main molecule? What is the substrate? What is the reagent that brings the change, right? That brings the change to the substrate. And at the end, we should get aldehyde. So remember, every reaction will give you aldehyde at last. Also, there will be something we will add, like baking soda we add, to support the reaction. So keep a notice of that also. So being said that, let's cook. Please note, if you are watching this video and want to learn these preparation methods, please write down with me. Don't watch this video as TV. We are going to do these reactions. Please note their names. So I'm going to prepare aldehyde by acyl chloride. Then I'll be preparing it with nitrile. Then the following two are with hydrocarbon as the main substrate. Here I'll be using chromium chloride as reagent. And then the second time, the same hydrocarbon I will take and I will do side chlorination and hydrolysis of that. And the fifth one is Gattermann-Koch reaction. Let's go one by one. So first, the main substrate is acyl chloride. Acyl chloride. So how we can make acyl chloride? We also say it acid chloride. So let's understand first what do you mean by how we prepare acid chloride. So chloride means chlorine. Remember that. So if you see a structure of acid like this, so why we are calling this acid? Because this guy can give its proton H positive. It can give, it can donate. So that's why we are calling it an acid. So remember that, can donate H positive. So that is why it is acid. Now, how we can make acid chloride? Just remove this OH and instead of that, put chlorine. So if we are able to do this, this will be our acyl chloride or acid chloride. Acyl chloride. Remember that. Okay. So it is a derivative from the acid. We have derived it from an acid. We have removed this OH and put chlorine, and we are calling it acyl chloride. So I will just write it here. It is a derivative of acid. Okay. Now, even with this information, can you tell me what you are going to do to prepare aldehyde? Always in any reaction, keep your aim what you want to prepare. We want to prepare aldehyde. So instead of chlorine, what you want? Hydrogen. Remember? So if we put one hydrogen here, we have at least one hydrogen, double bond, and other side we have alkyl group, our aldehyde will be prepared, right? So similarly, think like that. So the alkyl group which you are going to take, I can take benzene kind of structure like this. I can take this as alkyl group and I can have this structure. Instead of one hydrogen attached here, I'm just putting COOCl, acyl chloride, right? So what I want, don't want this, sir. I want H so that I can have my aldehyde. So you want H, have H. So we'll react it with hydrogen. And remember, we were talking about something like a supporting agent, which will help us in this reaction. So we use PD, so that is palladium, with barium sulfate. So I will write down the names so that you remember. So this is palladium, and we call that barium sulfate. Barium sulfate. Why we need this? because they control the reaction. In a way, support the reaction. So how many Cl we want here? This controls that it happens properly. So the palladium and barium sulfate helps us to control the reaction. So they are the controllers, controls the reaction. Yeah. So now, can you tell me what will happen? H has come, it will remove this Cl and we will get this. So this will remain like that. And now this, and we got H. And that's it. Our first reaction is done. So see how simple it is. So now one more thing. Some reactions are named reactions. They are named by some scientist. So we need to remember those names also. This acyl chloride reaction is popularly also known as Rosemond reaction. So in your exam, they can ask, what is a Rosemond reaction? And you need to explain this. Okay. So what we do is we take an acyl chloride. We take an acyl chloride. We react it with hydrogen in the presence of palladium and barium sulfate, which controls the reaction, and we get our aldehyde. I think my H is hidden. Okay, my H is hidden here. Sorry, I will just, I can draw it here, right? So H will be attached instead of this chlorine. First reaction done. So the second reaction or a preparation method is from nitrile. Nitrile, you can guess that there'll be some nitrogen. So this particular structure is called a nitrile. See, triple bond with nitrogen, nitrile. So first was acyl, now we have nitrile. So now first let's see the reaction. So what will happen? We have alkyl group attached with this carbon and we are having nitrogen here. Here is our nitrile group. We will add them up with tin chloride, SnCl2 plus HCl. This is an acid, right? So now it can give it H positive. So what will happen? I will show you what is happening here when we are doing this reaction. So this SnCl2 is just a promoter of this reaction, right? Always notice these kind of things. Who is promoting which reaction, right? So we are using tin chloride as a promoter. And this HCl, now this H will go here and attack this carbon and nitrogen. It will break one of the bond. So if you want to see the action, it will be like that. 3 and H positive are going to attack this. So they will form bonds here with carbon and nitrogen, and we will end up getting in the first step R C double bond N, and we have H here attached, and I can say H here attached. So one bond is gone, one pi bond is gone. Now is one sigma and one pi. And you know now clearly that our cooking is not done. This is the first step. So what is the next step? The next step is we will do a hydrolysis, like hydrolysis, or we write in in our book, in our textbooks like this, we are doing hydrolysis or reacting it with H3O positive. And remember what is a hydrolysis? Okay, hydrolysis, lysis means we are breaking. Let's see what we break, okay, in that. Okay, and then the hydro means water. So that is what the hydrolysis is. So now what will happen? So H3O positive, or you can think of like we have this. I'm showing in the slow motion now again. So we are here, CH double bond NH. So the H2O, right? The water, right? That can come. So think about it like H2 comes here and O comes here. So this is not right, right? I'm just oversimplifying it so that we understand. So now if these are mixed, NH, NH2, it will add up to NH3, ammonia, it's gone. We are not worried about it where it is gone, right? We are worried about this oxygen. So this oxygen, what it'll do, when it will get attached to this carbon, this will break these double bonds and get attached itself with the carbon with the double bond. So what we will get after hydrolysis, we will get R C double bond H. And remember, this reaction is also named one. So remember, this is by Stephen. This is also called Stephen reaction. Yeah. So N for nitrile, I guess. So remember like that. Okay. So let us revise what we have done. So we had a nitrile group. Here is alkyl group. C triple bond N is called nitrile. We added the HCl and tin chloride. This is a promoter. This is the main reagent. HCl. H positive attacked. One bond gone. CHNH it became. And then to cut these double bonds, now to break these bonds, we did hydrolysis. We added water, we can say. And now what will happen, that these double bonds will be cut, and instead of that, these double bonds will be attached to oxygen. Oxygen will make double bonds with this carbon, and we got our favorite aldehyde. So we have prepared the second reaction. With nitriles, there is another way in which, let's say, we had this nitrile group, right? So what we can do is we can have Dibal H. Dibal H? What is that? I know this as H. I will tell you the full form also. In the presence of water, H2O. And remember what every letter tells. So this is a compound. So I will tell you it's a di, I for iso, di-iso, B for butyl, aluminium, A, aluminium hydride, H, hydride dibal. So this is a reducing agent. Reducing agent. It can give H here, right? So now what will happen? Let's see. Remember, we have also H2O. So this is our nitrile. So we have oxygen from this will be attached from here, right? And one H from Dibal H, we will get one H attached here. What about this? Broken. We'll break these bonds. Okay, so that's what we will get our, that's how we will get our aldehyde. So from where it came, this oxygen came due to the presence of H2O. And from where H came, it came from Dibal H, right? Diisobutyl aluminum hydride. That's what the full name is. It's a reducing agent. So in nitrile, there are two ways. Remember that. Now let's go to the next reaction. Now, the third reaction is I'm going to prepare aldehyde from a hydrocarbon. And the hydrocarbon which I'm going to take is very popular. So here is a benzene ring. And if I attach a methyl group instead of one hydrogen, we get the structure of toluene. Sorry, what's the spelling? It is Toluene, toluene. We call this toluene, right? So one benzene attached with methyl. So this hydrocarbon I'm going to use. And watch my reagent. It is chromium chloride. Chromium chloride. Okay. Let me write chromyl chloride, not chromium, chromyl chloride. What is this? This has oxygen, right? So this is a oxidizing agent. This will give us oxygen attached with this carbon so that we can get our thing which we want, aldehyde. And we do this in the presence of carbon disulfide, CS2, CS2, carbon disulfide. Okay, and this is kind of a, you can say, works as a solvent, works as a solvent like medium, right? It's a, if you ask what is kind of solvent it is a non-polar solvent it is. So that's what we are going to use. So chromyl chloride will be the reagent which is having oxygen. So now what will happen? Let's see. So after we are doing this, we will get this. So this benzene ring is like that. So now watch out what happens. So think about, we have CH3 here. Let me have some space. Yeah, CH3 here. So C and one H say here, and watch what is connected instead of H2. So one H is there, but what happens H2? So we will get attached O Cr chromium O H Cl2 twice, because H2, like instead of H, right, this came. That's why it was CH3, right? So instead of H, this complex looking chromium compound has been attached, right? Chromium molecule is attached, and it is very complex. Don't you think? I understand totally. I get your point. That's why I will name it that we have prepared chromium complex. Yeah, it is complex, so we agree. Yeah, so remember its name. It is chromium complex. We have prepared chromium complex. So what is the next step we should do? It is not the final product. What we did last time? Oh, sir, you did hydrolysis. Same thing, we will do it here. So we will do hydrolysis. Now what it will do, instead of this, everything is gone. Will be gone like that. Okay, and only the oxygen will have bonded here. So that is what this hydrolysis will break. So we will get, we have space like that, and this will have H, and this we had got L. So we got the R aldehyde which we wanted. And this also have a scientist name. So I will write on the top. So from hydrocarbon, we added the region chromyl chloride, and this reaction is called Itard reaction. Scientist name again, it is called Itard reaction. So these scientist names are also important because they can ask you in exam like explain Itard reaction. So what we will say, we take a hydrocarbon, toluene, we will show this toluene, one methyl group attached with the benzene ring. We react it with chromyl chloride, right? Chromyl chloride, it's an oxidizing agent. Remember, oxygen is there. And we do that in presence of carbon disulfide. It's a solvent, non-polar solvent. And we get a complex looking structure like this. What we call that? We call it chromium complex. So what is that? CH, and in this, instead of H2, right? Two hydrogen were remaining. One is there, right? It was CH3. So instead of H2, we are getting OCrOHCl2. And this is called chromium complex. And to further get our aldehyde, we did a hydrolysis. And that it all cancels out, only this oxygen gets bonded with this carbon. So that's our Itard reaction for you. So here's the fourth reaction. It is similar to the previous one because we are going to use a hydrocarbon and we will use the same one. So I will use the toluene again. Benzene ring attached with methyl group. So I will use tol, this time no spelling mistake, toluene. Yeah, so I'll be using this, and whatever I will do, it is just written here. I will do chlorination and then following with hydrolysis. That's what most of the reactions we have done, right? We have done hydrolysis. Okay, so first I want to do chlorination. Okay, bring chlorine. So the reaction will be, I will add chlorine. Okay, remember that we can write here, or I can write here plus chlorine, same thing. So I'm just writing on top of this arrow chlorine, and we write something like H nu here. It means light, okay, in presence of light, nothing else. H nu is energy. Okay, so we just symbolically we are telling that this reaction is happening in the presence of light. So now this toluene and this chlorine, what they'll do? The chlorine will get attached, and we will get this. Okay, so remember, if you want to see this, okay, just like that. If you want to see, so you can imagine like that, H2 will be replaced by Cl2, so it will be CHCl2, and this has very famous name, benzyl chloride. So in the first step, what we did chlorination and we got benzyl chloride. Now you know the step, it is not the final product, so let's do hydrolysis. Symbolically, we show H3O positive. And now what it'll do, it'll break this Cl2. It'll go away, and oxygen, H2O, oxygen will play its part. And let's write here, okay? Let me have some space. Okay, so this we will get this CH double bond O. We got our aldehyde. So that's it for the fourth reaction. So let's finally do our last reaction. So this is the preparation for aldehyde, and this reaction is named as a Gattermann-Koch reaction, another scientist name. So now in this, I will use simple benzene ring. So let me draw this benzene ring like this. Okay, and the ingredients, the reagents in which this will happen is carbon monoxide, very dangerous gas, and just see the what other thing is HCl, another acid, dangerous. Yeah, so carbon monoxide and HCl, and I will use this reaction. I will do this reaction in presence of anhydrous aluminium chloride, AlCl3. You can use copper chloride also. So anhydrous means without water, remember that. Anhydrous, hydrous means water. We attach this An, it means without water. So now what will happen is, the main thing is these two guys. Okay, so what they will do is carbon monoxide plus HCl will give us what we want. So they will give us this group. That is what we need in aldehyde, right? And this guy will attack, and instead of one H attached, it will get attached here. So that is what it will happen. Okay, so carbon monoxide and HCl, they will give us this structure, and this will attack benzene and remove that hydrogen which is attached with this, let's say carbon, and get attached, and we will get final product like that, like that. We got our aldehyde. Now, before going, you must be wondering, so many things to remember, so many reactions and new names, fancy names, chromium chloride, something, something. How to remember? Just understand you don't have to. This video, if you have watched and written it down, just look that carefully and try to remember by the names. Like from acyl chloride, how you will make aldehyde. What is the reagent? What is the substrate? Like that, count these and put them in one page. And by name, try to remember that. Will it happen first time? No. If anyone seeing this video is getting if I'll show these reactions, you will remember them, what is happening. No. Just think them as stories, which we need to repeat. Put again this video, and now try to get ahead of me. When I say the name of reaction, you just draw whatever you want. Complete the reaction before me. And if you are stuck somewhere, my video will follow and then continue that. So go ahead with the video next time. Second thing, Discussions. Keep discussing these elements so that they are not fancy to you. You will understand that how easy it is. But cramming will not help. Discussions, remembering, recalling will help you. Thank you.